All right, the first thing you're going to do, guys, turn the radian mode into degree mode. So click on mode, and then click on degree, enter. So if you have a brand new calculator, it'll say degree, but if not, you have the older ones, you got to make sure that it says degree. Do you have a TI, is that a TI 89 or, oh, TI 83? Yeah, it's almost the same. Yeah, that's fine. It's practically the same, but there's a little SAT. Okay, yeah. It's almost the same, almost. There's a few differences, but for the most part, 83 and 84 are real similar. All right, cotangent of 38 degrees. Cotangent is the reciprocal of tangent. So what you're going to do, take your calculator, push tan of 38, push enter, and then the reciprocal button is this one right here. Do you see it? It's underneath the math. Do you see it where it says x to the negative 1? Push that button, and it should say that. So there's my answer, 1.2799. You could also do, if you don't like that, you could also say 1 divided by, we said cotangent, right? So 1 by tan of 38, and it should be the same answer. Check it out, enter. It's the same digit per digit. So any one of those two options is appropriate. That's the answer, so write that number down. 1.2799 for cotangent 38. 1.2799, and we're in degree mode. So cotangent of 140 degrees. So I take my calculator out, and I can either go 1 divided by tan of 140, or I can push tan of 140, push enter, or I guess you could also push the reciprocal sign immediately. But I like to do that and then push this button. So negative 1.191 or 192. Negative 1.192. You should not be surprised that it's negative, because at 140 degrees, x divided by y is negative. Secant of 238. Secant is the reciprocal of cosine, so I push cosine 238. I push enter. I push the reciprocal button. I push enter again. Negative 1.8871. Negative 1.8871. That's an equals. All right, secant of 53. So that's the reciprocal of cosine again. So cosine 53. Push enter. Push the reciprocal button. Push enter. 1.6616. 1.6616. Okay, cosecant is the reciprocal of sine. So I can do, let's see, I'm going to do it differently. 1 divided by sine, and it said negative 179, right? So there it is. Negative 57.2986 or 2987. Negative 57.2987. Cosecant of 180, that's a reciprocal of sine. Sine of 180 is what? 0, so it's going to be undefined. Sine 180, enter 0. If I take the reciprocal or try to take the reciprocal, I'll get an error. So that one is undefined, guys. Undefined. Undefined. If we're being technical, you really shouldn't be using equal signs because the equal sign is really for like it equals a number or equals something, but that's fine. That was a review. Maybe it wasn't a review because we haven't done enough of them, but it's supposed to be like a little review. All right. Have you worked with waves before? Yeah, but guys, waves are all over the place. Right now, you are being bombarded by light waves that are going into your eyes. Right now, you're being bombarded by sound waves that are going into your ears. It literally is a wave, up and down, up and down, up and down. And that wave echoes into your ear, and it hits your eardrum, and you get to hear this that you hear. In space, there is no air, so there is no sound waves. It's a vacuum. So you need something like air or something for the wave to propagate. Make sense, guys? All right, so draw a wave. Make it big. And make it a wave that is the same height for the peaks and the same mins. So what do we know about waves? Let's see. We know that this is concave down. See, it's like a bowl upside down. We know that this is concave up. This line that's going right through the middle is either called a midline and it's also sometimes called a sinusoidal axis. These points right here are called points of inflection. They call them points of inflection because it's a point where you change concavity. That's what inflection point is. So put that down in your notes, guys. The point of inflection changes concavity. Let's see, what else? The period. Peak to peak. It doesn't have to be peak to peak, guys. It could be point of inflection going up to point of inflection going up. But peak to peak, that is called a period. You can also call it one cycle. Peak to peak, one period, one cycle. Let's see, am I missing anything? If I were to call this a y-axis, then this is called a max. And this is called a min. I think we're good. Oh, the amplitude. Amplitude is the distance from the midline to the peak. You could also call it the distance from the minimum to the midline. That's the same thing. All right. I think I've covered everything. Yeah. Okay. I think we're good. So if you switch, it says general sinusoidal equations. Yes, I know that this has a cosine on it, but it's still a wave. So all waves are called sinusoids. Do we understand that, guys? So cosine's a wave, and all waves are called sinusoids. It's just a cosine, but it's still, okay, it's still a wave. The B tells you your horizontal stretch or compression from just like algebra 1 and algebra 2. Your A is your amplitude. B is stretch or compress, but horizontally. Horizontal stretch and compress. The C is your shift, your horizontal shift. Sometimes they call that the phase shift. And the D is a vertical shift. Sorry, I noticed that I'm noticing that my laptop needs calibration. So if you're wondering, what is he doing? It's a little off. Look, and I know you guys can't see that little red dot there, but I've noticed it's like about a millimeter off, which it doesn't sound like much, but it's enough to annoy you when you're writing. Imagine you're writing on paper and it's off just by a little bit. Wouldn't that annoy you? Okay, anyways, sorry guys. All right, the period. How do you figure out the period of any graph? Peak to peak, point of inflection to point of inflection. So yeah, I guess that's it, guys. And then here's some formulas, how to figure out what the B is. So what this tells you is how to figure out your horizontal stretch or compression, the B. So the B is nothing more than 360 degrees divided by the period. Or if you're in radians, the B is equal to 2 pi divided by the period. Remember that sine and cosine by themselves have a period of 2 pi. Cool? All right. So let's see if you guys remember your unit circle. I'm going to sketch this. So sketch it like so. I'm going to make a max. The amplitude is 1, so go to 1. Here's 1. I'm not going to pass that. And then go to -1. You're not going to go below that. And we're going to start with points, guys. What is, and I guess let's put perfect ones here. So 0, pi over 2, pi, 3 pi over 2. No, Yanni. That's a demerit. 2 pi. What is sine of 0? Zero. Put a point at 0, 0. What is sine of pi over 2? Not everyone at the same time. Sine of pi over 2, guys. It's right on the y-axis.
Oh, it's 2. I always forget there's 2.
So sine of pi over 2 is not 0. 1. Sine of pi over 2 is 1. Sine of pi, that's 0. Sine of 3 pi over 2, -1. And then finally, sine of 2 pi, 0. And if I were to go backwards here and say this is negative pi over 2, sine of negative pi over 2 is -1. That's equivalent to 3 pi over 2. Here's what you're going to do. On the maximums, draw a concave down, but make it point towards those zeros there. On the mins, draw a concave up. And now connect them to the x-axis. Try to make the x-axis a point of inflection. And there you go. Look at that. You got your first sinusoidal graph. Isn't that cool? I want you to notice that sine graph, the y equals sine x, has a point of inflection at the origin. So we're not going to start graphing the sine x. We're going to start with the cosine x, and you'll see why. So I'm gonna sketch again. And we're going to do the same thing, guys. 1, -1, negative pi over 2, pi over 2, pi, 3 pi over 2, 2 pi. Okay. You guys ready? Cosine of 0. I don't know. Cosine of 0 is not 0. 1. So go to 0, put a point at 1. Cosine of pi over 2. 0. Cosine of pi. -1. Cosine of 3 pi over 2. 0. And then cosine of 2 pi. 1. You've done a whole revolution. Cosine of negative pi over 2 is 0 again, guys. So I'm going to put 0 there. And now I'm going to graph them. All the max, concave down. All the mins, concave up. And now try to connect them to the x-axis there. Make the x-axis a point of inflection. And check it out. You have your first cosine graph. Isn't that cool? Okay. We are going to start by graphing a whole bunch of cosine graphs. Why? It's the one that's easier because I have a peak right on the y-axis, so I can move that around as much as I want from the peak. Does that make sense, guys? And don't worry, we're going to do this together until you guys feel comfortable. It says, suppose that a sinusoidal axis has a period of 12 degrees per cycle. The amplitude is 7 units, so I'm underlining stuff that's important, and the phase displacement is -4. with respect to the parent cosine function and sinusoidal axis 5 units below the x-axis. Okay, so sketch a graph. All right, let's sketch a graph. So here we go. I'm just going to go, and it says, let's see, 5 axis below. So I'm going to put my x-axis right here. That's my x-axis. They told me that my sinusoidal axis, it says 5 units below the x-axis. So I'm going to say right here is -5. And I'm going to do a dash line. So this is my midline, guys. Midline or sinusoidal axis. It's the same thing. It's the middle. I got half the wave above that red line. I got half the wave below that red line. Are we okay? All right, here we go. I'm going to sketch my max and I'm going to sketch my min. I know that the amplitude is 7. So if the amplitude is 7, what is -5 plus 7? So go to 2 and put a dashed line. You're not going to pass that 2 there. And then I'm going to go below that -5. What's -5 minus 7? So -12. So I'll go down here to -12. You're not going to go below that. I'm trying to make it symmetric. Let's see. Does it look symmetric? Maybe this should be a little below that. Let me make it a little more below. Oh man, I deleted my. There we go. I'm trying to right there. There, now it looks good. Okay, here we go. What was my face displacement? 4 to the left. So go 4 to the left. I'm going to say 4 to the left. Let me stretch this a little more. I'm going to say 4 to the left is, and it's not drawn to scale. It's not perfect. I'm going to say 4 to the left is like right here. Now, it says that I want to have a period of 12. So I'm going to try to make it symmetric. So the next peak, so I have a peak at -4.2. So put a point at -4.2. Does everyone know why I got a peak at -4.2? Because it told me that I have a phase displacement of -4, and I'm using the cosine. So the cosine has a peak on the y-axis, so I move that 4 to the left. Does that make sense, guys? Okay. Now, every 12 degrees, I repeat. So I'm going to try to make it symmetric. Let's see, 4, 8, 12. I kind of see it like right here. Point. And that's not 12. The period is 12. What number is that? The x-axis. What do you think it is? What number do you think this is? Hashtag. Remember, the period is 12, guys. So if I have a peak at -4, 12 degrees later, I have another peak. So it's going to be at 8. Good job. Don't be scared, guys. It's okay if we're wrong. What's the worst that's going to happen? All right, repeat it every 12. So let me see if I can get that gap correct. Gap, gap. So I have another one right there. That's going to be at 20. 12 plus 8 is 20. I'm going to keep going. I'm going to go another 12. Let's see. I'm going to say right there. I'm just measuring it with my fingers, guys. And I'm going to say that is 32. I think that's enough. I think that's enough. Okay. How do we feel so far? Okay, so here we go. Ready to get the minimum? Between the two peaks, I have a min. So just kind of look at it with your eye more or less. And it's going to be something like right there. Chav, how do you know where it's at? It's going to be at 2. Because if the period is 12, that means I got to go halfway. So -4 plus 6 is at 2. Do you guys see how we did it? Now that minimum repeats every 12. So 2. So the next one's going to be at 14. And the 14 better be the middle between 8 and 20. It is. 8, 9, 10, 11, 12, 13, 14. It's 6, 14 is 6 away from 8, and it's also 6 away from 20. Do you see how it's the middle? All right, do another one. From 14, go right to the smack in the middle between 20 and 32. Min. And that's going to be 14, 24, 26. So there it is. Are we still okay? All right, every quarter between the max and the min, that's 50%, right? So every quarter there's a point of inflection. So let's see, from -4 to 2 is going to be, what's half of, so at 3, -3, so it's going to be -1 right there. Chavez, what did you do? The distance between -4 and 2 is 6. I need half of that, so 3. I went -4 plus 3 at -1, there should be a point of inflection. Right on the midline, cool? Okay, between the 2 and the 8, there should be a point of inflection right at the midline. If you want to know where that one's at, 2, 3, 4, 5, that's at 5. Between the 8 and the 14, there's a point of inflection, point. 8, 9, 10, 11, point. Between the 14 and the 20, point of inflection. Between the 20 and the 26, point of inflection. You guys get the deal? Put points. That's at 23, 29. You don't have to be that specific, guys. I'm just putting in there so we can know. I think we have everything we need. Wherever you have a max, put concave downs. Put bowls, concave downs. Try to make it where you're aiming towards the point of inflection. Wherever you have a min, concave up. Concave down, concave up. I always do the bowls first. Concave up, concave down. All right, now I'm going to connect them to the points of inflection. Try to make the point of inflection where it changes concavity. Concave down, concave up. If you have to fix your concave up, concave down from your bowls that you have at the max and mins, that's fine. And check it out. There it is. How do you feel? All right. Don't worry, guys. We're almost done. Find the equation for this graph. Here's what helps everyone. Always, 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 just write this equation over and over again. So here it is. All right, y equals a cosine, open parenthesis, b, open parenthesis again, x minus c, close, close, plus d. I'm just going down the alphabet. A, B, C, D. Are we okay? Do we know what the amplitude is? 7. So write a equals 7 on the side. Do we know what my phase shift is? The C. What was the C? Phase displacement. That's my C. What is it? -4. Negative times the negative is going to be a positive. So C, for just leave it as -4. The D. The D is your midline or your sinusoidal axis. Where's my midline at? -5. Okay, how do I get the B? Look at up here for your formulas. We get the B by doing 360, because we're in degree mode, divided by the period. Do you guys see that? So, here's the B. 360 divided by, what was this period? 12. So, you take your calculator, and you're going to go 360 divided by 12. 360 divided by 12, 30. Okay, we got everything, guys. So here's our equation. Y equals 7 cosine, open parenthesis, 30, open another parenthesis, x minus a -4, so it's going to turn to a positive, close, close, minus 5. Let's check to see if we're correct. Everyone type it into your calculator, guys. I want you guys to see. So y equals, what was the equation again? 7 cosine 30, and then open another parenthesis, x plus 4. Close it twice. 1, 2. That's the number one mistake that we make. Minus 5, right? Okay, don't push graph yet. We got to fix our window. This is how the graph is looking. So let me go back to my notes. Look how I have my window, guys. The midline's at negative 5. The max is at 2. The min's at negative 12. And I go from negative 4 all the way to 32. So I click on something that says window. Do you see the window button? It's next to the y equals. Click on window. And I'm going to say x min. I want it to be negative 7. I want to go a little bit to the left of negative 4. X max, I want it to be, let's put 40. X scale, let's go by 5s. It doesn't matter. Y min, I have negative 12, so I'm going to go negative 16 because I want to see it within the graph. Y max, I go all the way to 2, so let's put like 5 or 6. Y scale, go by 5s again. Push graph. Do you have a graph that looks something like this? Okay, where are you at? Yeah, try it out, guys. Try it out. We need to get better at using these TI-84s because you can be so fast with these calculators, guys. So fast. Way faster than the Inspire. No, yeah. The Inspire is a stronger calculator, but what's the point of a stronger calculator if we don't know how to, like if you can't be fast with it, you know what I mean? Okay. I push graph. Here's my equation. How do I test it? You see the button that says trace? Push the trace button. And then I just put negative 4 and I push enter. At negative 4, do I have a max of 2? Yes, I do. And then if I want to check my point of inflection, let's see. I know that I have a point of inflection at negative 1. So I'm going to push negative 1. Now I can just push negative 1 in here and push enter. Do I have a point at negative 1, negative 5? Yes. Now let's see. I know that I have a minimum at 2. So I'm going to push up 2 button. I'm just going to push 2 and enter. And do I have a minimum at negative 12 at 2, negative 12? And there it is. Look how awesome that was, guys. What did you think? Cool, right? Ask me. What's up, lettuce? The maximum was at 2. If you want to see all 3 points, you can do this. Watch. At Y2, you can push 2. At Y3, you can put negative 5 for the midline. And then at Y4, you can put negative 12. And check it out. Look how awesome this graph is going to look. Oh, yeah, look. There's my max. There's my mid. And now, if you want, you can push, let's see, you can go second calculate. You can push the word intersect, number 5. And then you can find the intersection between any curve now. Go down. And then look. It's telling me that I have an intersection at 17, negative 5. Do I have a point of inflection at 17? 14. Yep, I do. I just didn't put it in here, but that's 17 right there. Cool, right? It didn't work? All right, let me see. Anyone else? Good? Good? Yeah, plot one on. Yeah, sure. All right. Hopefully now you guys feel super beast. Now let's go the other way around, guys. Here's a graph. Example 2. It says from the sinusoid below, give the period, frequency, amplitude, phase displacement, and sinusoidal axis location for a particular equation of the sinusoid. Okay. In my opinion, this is just my opinion, I think the easiest thing to do is find the middle. How do you find the middle of anything? Especially when there's just one max and one min. You add them and divide by 2. So the midline, or sinusoidal axis, it's the same thing. The midline is, the maximum is at 56, plus the minimum is at negative 38, and divide by 2. So I take my calculator, and I'm going to go 56 plus a negative 38, or if you want to go 56 minus 38, it's the same thing. Enter, divide by 2, enter. My midline's at 9. So I look at this thing and I say, let's see, what's the scale? 10, 20, 30, 40, 50? So it's probably barely right below this one at 10. But you're not right at it. You're a little below it. My midline is 9. From there, I can find my amplitude. For my amplitude, let's see, the peak is at 56. My midline is 9. So just go 56 minus 9. What's that? 47. That's your amplitude. So now I got my amplitude, I got my midline, now I need my phase displacement. If I'm using cosine, where is that peak? It should have been right on the y-axis, but it's not. Give me the x value of that peak. What's the x value, guys? 3. So the phase displacement, you can say 3 to the right. We're talking in terms of cosine. In terms of cosine. Okay, I got almost everything I need. Well, I still haven't answered the other question. I haven't answered the period question. Period. Peak to peak. That's not the only way you can figure out the period, guys. That's one of the ways. I have a peak at 3. I have another peak at 23. So the period is, 23 minus 3, which is 20. How do I find the frequency? The frequency is the reciprocal of the period. So frequency equals 1/20th. If this were time in seconds, you would call that a hertz. Don't hertz me. I thought it was funny, but maybe you guys didn't. All right, I got everything, guys. I got the period, I got the frequency, I got the amplitude, I got the phase displacement. I got everything I need. So here we go. Go down the alphabet. Y equals A, cosine, open parenthesis, B, open parenthesis, X minus C, close, close, plus D. I just went down the alphabet. A, B, C, D. So here's my equation. Y equals, what was my amplitude? 47. Cosine, open parenthesis. I haven't calculated the B yet, so go to the side. B equals, how did I calculate the B? 360 divided by period. The period was 20, so I take my calculator, and I'm going to go 360 over 20, and hopefully it gives me a nice little number. It does, 18. So I come back, 18, open up another parenthesis, x minus, what was my phase displacement? 3, so x minus 3, close, close, And then what was my midline? 9. Check to see if we got it right. Type that into your calculator fast. There's a y equals button. So I'll just go y equals. I clear it. I'm going to clear everything I have in here. I just push the clear button. And then I start typing what I have. Let's see, 47 cosine. I want to say it was 18, right? When you push cosine, it already opens a parenthesis for you. Open up another one. X minus 3. Close, close. Put 2 parentheses there, guys. And then what was the midline? I already forgot. 9. So plus 9. Don't push graph yet, because it's not going to graph it. Click on window. Let's see. X min. I got to look at my X min. I go from, let's go from negative 5 all the way to 30. So negative 5. X max 30. X scale 5. That's fine. Y min. So let me go back to my window. It goes all the way to negative 38. So let's go to negative 50. Negative 50 all the way to, what was my Y max? 56. So let's go all the way to 75. And because there's so many of them, I want my scale to be by 10. And then don't worry about X resolution. Now push graph. And there it is. I want to check to see if it's correct. What button do I push? The trace button, right? Trace. And then I'm going to check at 3 if I have a max there. So push trace 3. Enter. Do I have a max at 56? All right, I want to check the other max. It says at 23, I should be at 56. So just push 23 now. Enter. Yep. Now I want to check the minimum. I have a minimum at 13. So push 13, enter. And yep, it all works. Do you guys see how we did it? Flores, you okay? For sure. Martichan? All right. Is this new stuff for you guys, or you guys have never have done this before? So do you feel empowered that you just learned something super awesome? Yeah! Okay. I always get hyped, guys. I get so hyped. All right, one more. One more. Question example 3. All of these are with cosine, because that's all we know right now. The figure below, oh, by the way, if you're wondering, when am I ever going to use this? If you become an engineer, you're going to be using this all the time, guys. How do you think your phone works? It's all signals. It's all millimeter waves from 5G. So without this, right now, you're learning the stuff. You are learning math that it takes to require for your cell phones to work, for your computers to work, for the stuff that you love, TikTok, all that. You're learning that math that requires it for all that to work, guys. All right, let's read this. The figure below shows a quarter cycle. A quarter cycle, so that is what percentage? 25%. So put 25% somewhere in there of a sinusoid. Write a particular equation and check it by plotting it on your graphing calculator. Okay, this is 25%. So I notice that this is concave down. So this 3 is a minimum. This is a minimum, guys. And this at 8 has to be the midline or the sinusoidal axis. Midline. So let me see if I can draw. Let's see. This is a point of inflection. Minimum right there to 24. So let's see if I can draw the other 25%. So the gap between 17 and 24, what's that? 17, 18, 19, 20, 21, 22, 24. Is that 7 degrees? Okay, go another 7 degrees from the 24. Go like that. And that should be at 24 plus 7. Is that 31? So at 31 degrees, I have another point of inflection. Go another 7 degrees, and you should be at a max. And I didn't draw the max. Okay, hold on real quick. The difference between 8 and 3 is 5, right? So go another 5 on top of 8. So what's 8 plus 5? 8, 9, 10, 11, 12, 13. So go to 13, and then just do an imaginary line up there. So you can use that as a reference. All right. I'm going to try to keep the grid the same, guys. So this is 7 degrees. So let me see if I can go another 7. I'm going to say another 7 is like that gap, and I'm going to say that's 38 degrees. So let's see. Go another 7, concave down, put a peak at the 38. Concave down, bam. And I'm going to keep going until I've completed a whole cycle. So I'm going to go another 7. Yeah. 38, 9, 44, 42, 43, 45. So I'm going to say 45 right here. Point of inflection. And there it is. I've completed a whole cycle, guys. Chavez, how do you know? This is a point of inflection going down, point of inflection going up, point of inflection going down. And you can also see the quarters. 1 quarter, 2nd quarter, another quarter, 7 degrees, another quarter, 7 degrees. 4 of them make up a whole cycle. Do you guys see that? All right, what do they want? They want the equation. All right, so I'm going to go down the alphabet. Y equals A cosine, open parenthesis, B, open parenthesis, X minus C, close, close, plus D. It does not matter, and I know some of you are going to think, okay, let's just go down the line first. What do we already know? We know the midline. So we know D is 8, right? We know A, the amplitude is 5. We know B, well, kind of. B is 360 divided by, not 7. What's 7 times 4? 360 divided by 28. Make sure you put in there that the period is 28 degrees. I'll fix it right now. The C can be any peak. And I know some of you are thinking, Chop, I can go another 7 to the left of 17, so at 10 degrees, and I'll be right there. I can use that peak at 10. You are right. You can. But it can be any peak. It doesn't have to be 10 degrees. It could also be which one? Which one do I have? Was I graph first? The 38. It could also be the 38, guys. So I'm going to put 38 degrees. I'm going to put 38 degrees in here. 38 degrees. All right, so here we go, guys. We got everything. Y equals, well, let me do what 360 divided by 28 is. It might be a fraction. And I don't think it's going to be a pretty number. 360 divided by 28. Do not leave it like this. Do not put down that fraction because it goes on forever. Just turn it, not decimal, sorry, not a fraction. Just turn it into a fraction. 90 over 7. 90 over 7. Okay, here we go. 5 cosine, open parenthesis, 90 over 7, open another one, x minus 38, close, close, plus 8. If we're in degree mode, you usually want to put a degree in there, but it's not going to be a big deal if you don't put it in there. And there it is, guys. And then I would check it if I were you. So how do you check it? You go to the calculator, and I'm gonna go back to y equals. I'm gonna clear this one, and I already forgot short-term memory. 5 cosine. So I put 5 cosine, and then you can use the alpha fraction feature like that, and you can put 90 over 7. Oops. Just go down 7. You don't have to if you don't want to. I already went out of there. And open another parenthesis. And then I already forgot. X minus 38. Close, close. And then plus 8. All right, let's see. Window. And then I just make it fit to that, guys. 0 to 45 or 0 to 50. 0 to 50. Scales by 5, that's fine. Y min 0 to 8, 9, 10, 11, 12, 13, 0 to 15. 0 to 15. Scale by 1. And let's graph. And there it is. Let's see if we're correct. I know for a fact that at 17, I better be at 8. So trace 17. Enter. Yep, it's at 8. I know for a fact that at 24, I better be at 3. So I just push 24. Enter. Yep, it's at 3. It works. How do we feel? Okay, these are all skills, guys, that you're going to have to be good at. Not just because of this class, but in the future, who do you think is going to be calibrating the machines at the hospital? Are you going to go to med school? you're going to be a doctor, and you're going to be, so if you're like, man, what am I going to use this? Well, you're going to have a machine, and you're going to have to calibrate it. So it's the same with this. All right, guys, we're done. Go to Mexico because you want it. And see, look, you can work this with your fruit. See how many you can do. All of them can be done with cosines. All of them. So knock it out of the park. Check your answer. Check your work. And we're done, guys. You can also check with Desmos if you don't have a graphing calculator at home. Good to be back. Good first day.